This is the EdExcel AS Level Further Maths Paper 1 covering the Core Pure module, and this is from the 2024 series. Question number 1. The cubic equation 2x cubed subtract 3x squared plus 5x plus 7 equals 0 has roots alpha, beta and gamma. Before we do anything else, let's divide each term of the cubic by 2. So we will be left with x cubed subtract 3 over 2 x squared plus 5 over 2x plus 7 over 2 equals 0. And if the cubic has roots alpha, beta and gamma, then alpha plus beta plus gamma, that will equal negative 3 over 2, which is 3 over 2. Alpha beta plus alpha gamma plus beta gamma, that will equal 5 over 2, and alpha beta gamma will equal negative 7 over 2. Without solving the equation, determine the exact value of alpha squared plus beta squared plus gamma squared for part 1. Alpha squared plus beta squared plus gamma squared, that's equal to alpha plus beta plus gamma squared subtract 2 times by alpha beta plus alpha gamma plus beta gamma. And we know what alpha plus beta plus gamma is, that's 3 over 2. We know what alpha beta plus alpha gamma plus beta gamma is, that's 5 over 2. So we have 3 over 2 squared subtract 2 multiplied by 5 over 2. So let's work this out. We have 3 over 2 squared subtract 2 multiplied by 5 over 2. It turns out we get negative 11 over 4. We now have to determine the exact value of 3 over alpha plus 3 over beta plus 3 over gamma. 3 over alpha plus 3 over beta plus 3 over gamma, well, we can find an equivalent expression. We have a common denominator of alpha, beta, gamma. And so, for the first term, we have 3 beta gamma. For the next term, we have 3 alpha gamma. And for the final term, we have 3 alpha beta. So, we have 3 multiplied by alpha beta plus alpha gamma plus beta gamma divided by alpha beta gamma. And we know what alpha beta plus alpha gamma plus beta gamma is, that's 5 over 2. And we know what alpha beta gamma is, that's negative 7 over 2. So we have 3 multiplied by 5 over 2 divided by negative 7 over 2. So let's work this out. We have 3 multiplied by 5 over 2 divided by negative 7 over 2. It turns out we get negative 15 over 7. We now have to work out the exact value of 5 subtract alpha multiplied by 5 subtract beta multiplied by 5 subtract gamma. 5 subtract alpha multiplied by 5 subtract beta multiplied by 5 subtract gamma, well, we have this 5 subtract alpha, and then we need to multiply together 5 subtract beta multiplied by 5 subtract gamma. 5 times by 5, that's 25. Then we have 5 times by negative gamma, that's negative 5 gamma. Then we have negative beta times by 5, that's negative 5 beta. And then we have negative beta times by negative gamma, that's positive beta gamma. So now we need to multiply these together. We have 5 times by 25, which is 125. Then we have 5 times by negative 5 gamma, that's negative 25 gamma. Then we have 5 times by negative 5 beta, that's negative 25 beta. Then we have 5 times by 5 beta gamma, that's 5 beta gamma. Then we have negative alpha times by 25, which is negative 25 alpha. Then we have negative alpha multiplied by negative 5 gamma, which is positive 5 alpha gamma. Then we have negative alpha multiplied by negative 5 beta, which is positive 5 alpha beta. And then we have negative alpha multiplied by beta gamma, which is negative alpha beta gamma. So we have 125, subtract 25 multiplied by alpha plus beta plus gamma, plus 5 multiplied by alpha beta plus alpha gamma plus beta gamma, subtract alpha beta gamma. And we know what each of those are. And by substituting in, we have 125, subtract 25 multiplied by 3 over 2, plus 5 multiplied by 5 over 2, subtract negative 7 over 2. So let's work this out. We have 125, subtract 25 multiplied by 3 over 2, plus 5 multiplied by 5 over 2, subtract negative 7 over 2. And if we work this out, we end up with 207 over 2. With respect to the right-hand rule, a rotation through theta degrees anticlockwise about the z-axis is represented by this matrix. Given that the matrix M, shown here, represents a rotation through alpha degrees anticlockwise about the z-axis with respect to the right-hand rule, for part A we have to determine the value of alpha. What we can do here is compare the elements. We would have the cosine of alpha degrees equaling negative root 3 over 2, and we would have the sine of alpha degrees equaling negative 1/2. So we have cos alpha degrees equaling negative root 3 over 2, and sine of alpha degrees equaling negative 1/2. Now if we solve these equations, begin by solving the first equation. You will find alpha to equal 150 degrees and 210 degrees, and solving the second equation, you will find alpha to equal negative 30 degrees and 210 degrees, meaning alpha is equal to 210 degrees. Part B, hence determine the smallest possible positive integer value of k for which the matrix M to the power of k is equal to the identity matrix I. So we've got M to the k equals I. Now what this means is, after applying the rotation k times, we return to the origin. In other words, 210k needs to be a multiple of 360 because we return to the origin. So we've got 210k equals 360n because we've got multiples of 360, meaning k is equal to 12n over 7. Now, as k is an integer, that would mean n will equal 7, and that's because we would have 12 times by 7 over 7, which is just 12. In other words, the smallest value of k is 12. The 3 by 3 matrix N represents a reflection in the plane with equation y equals 0. Part C, write down the matrix N. If we reflect in the plane y equals 0, the matrix N will be shown here. We have 1, 0, 0, 0, negative 1, 0, 0, 0, 1. The point A has coordinates negative 2, 4, 3. The point B is the image of the point A under the transformation represented by matrix M, followed by the transformation represented by matrix N. Part D. Show that the coordinates of B are 2 plus root 3, 2 root 3 subtract 1, 3. The matrix B will equal N, M, A. The order here does matter. What we are doing here is we are applying matrix M to A and follow that by applying matrix N. So we've got N, which is shown here in part C, followed by the matrix M, which is shown here, followed by the point A, shown here. Here we have to work right to left. So we've got the matrix N, that remains unchanged, and now we have to multiply M and A. So here we would have negative root 3 over 2 times by negative 2 plus a half times by 4 plus 0 times by 3. That's root 3 plus 2. Then we have negative 1 half times by negative 2 plus negative root 3 over 2 times 4 plus 0 times by 3. That's 1 subtract 2 root 3. And then we have 0 times by negative 2 plus 0 times by 4 plus 1 multiplied by 3, which is 3. So here we would have 1 times by root 3 plus 2 plus 0 times by 1 subtract 2 root 3 plus 0 times by 3. That's root 3 plus 2. Then we would have 0 times by root 3 plus 2 plus negative 1 times by 1 subtract 2 root 3 plus 0 times by 3, which is 2 root 3 subtract 1. And then we would have 0 times by root 3 plus 2 plus 0 times by 1 subtract 2 root 3 plus 1 times by root 3, which is 3. And that certainly is the point B. Given that O is the origin, part E, show that to 3 significant figures, the size of angle AOB is 66.9 degrees. For this question, we would have to use vector OA dot with OB is equal to magnitude of OA times magnitude of OB times cos theta. So let's begin by working out vector OA dot with OB. That's equal to, well, I've got OA, which is negative 2, 4, 3, and then need to dot this with the vector OB, which is root 3 plus 2, 2 root 3 subtract 1, 3. So I've got negative 2 times by root 3 plus 2, plus 4 multiplied by 2 root 3 subtract 1, plus 3 multiplied by 3. And if I work out what this is, I end up with 1 plus 6 root 3. We now need to work out the magnitude of OA and OB. So the magnitude of OA, that's equal to the square root of negative 2 squared plus 4 squared plus 3 squared, and that's equal to root 29. The magnitude of OB, that's equal to the square root of root 3 plus 2 squared plus 2 root 3 subtract 1 squared plus 3 squared. Let's work this out. We've got the square root of root 3 plus 2 squared plus 2 root 3 subtract 1 squared plus 3 squared, which is equal to root 29. So now we need to use this formula here. So I've got 1 plus 6 root 3 equals root 29 times root 29 multiplied by cos theta. So cos theta is equal to 1 plus 6 root 3 over 29. We can now find out what theta is. We would have the inverse cosine of 1 plus 6 root 3 over 29, which is equal to 66.868, etc. So in other words, theta is equal to 66.9 degrees. Part F, hence determine the area of triangle AOB, giving your answer to 3 significant figures. The area will equal a half times by root 29 times root 29 times by the sine of 66.9 degrees. So let's work this out. I've got a half times by root 29 times root 29, which is just 29, multiplied by the sine of 66.86, etc. And it turns out the area will equal 13.3 units squared. Question number 3, part A. Use these standard results for summations to show that for all positive integers n, the sum of r squared times r plus 1 from r equals 1 to r equals n is equal to 1/12 times n plus 1 times n plus 2 times a n plus b, where a and b are integers to be determined. For this question, we would have to use the standard formula, and that is shown here. We have this formula, and if we expand r squared times r plus 1, we end up with r cubed plus r squared. And don't forget, we need to apply the summation to these. So using the standard formula for r cubed and r squared that we've just seen in the formula book, this term here will equal n squared times n plus 1 squared over 4, and this term here will be n times n plus 1 times 2n plus 1 over 6. Now what we can do is rewrite this such that we've got a common denominator of 12. So we've got 3 over 12 times by n squared times n plus 1 squared plus 2 over 12 times by n times n plus 1 times 2n plus 1. Now you will find an n and an n plus 1, and the 1/12 is common to both terms. And therefore we multiply this by, well here, n times n plus 1 times by 3n times by n plus 1 would give me 3n squared times n plus 1 squared, and n times by n plus 1 times by 2 times by 2n plus 1 gives me 2n times n plus 1 times 2n plus 1. Continuing, we have n times by n plus 1 times by, now if I expand the brackets here and simplify, we have 3n squared plus 7n plus 2, and we divide this by 12. So I've got n times by n plus 1, and the 3n squared plus 7n plus 2 I can factorize as n plus 2 times 3n plus 1, and I divide all this by 12, meaning a is 3, b is 1. Part B, hence show that for all positive integers k, the sum of r squared times r plus 1 from r equals k plus 1 to 3k is equal to 1/3 k times 3k plus 1 times ak squared plus bk plus c, where a, b and c are integers to be determined. We have this summation which we can rewrite. You will notice here we are starting from r equals k plus 1, but in our formula we started off with r equals 1. So we can rewrite this as the sum of r squared times r plus 1 from r equals 1 to 3k, and then we subtract from this the first k terms. In other words, we subtract from this the sum of r squared times r plus 1 from r equals 1 to r equals k. What we can now do is recognize we've already worked what this is. Instead of us having an n, we've got a 3k and a k. So we can use the result here. We replace n with 3k, and we also replace n with k. So I've got 3k times by 3k plus 1 times 3k plus 2 times 3 times 3k plus 1 over 12, subtract k times by k plus 1 times k plus 2 times by 3k plus 1 over 12. So let's continue working all this out. We have a k times by 3k plus 1 over 12 as a common factor, and k times by 3k plus 1 times by 3 times by 3k plus 2 times by this term, which is 9k plus 1, would give us this first term here, and we subtract from this. Well, if k and the 3k plus 1 is a common factor, we would have to multiply that by k plus 1 times k plus 2. So let's continue simplifying. We've got k times by 3k plus 1, and then here I've got 3 times by 3k plus 2 times 9k plus 1, and these two brackets will simplify to 27k squared plus 21k plus 2, and we subtract from this k plus 1 times k plus 2, or in other words k squared plus 3k plus 2, and we divide all this by 12. So we have k times by 3k plus 1, and then we have to do 3 times by 27k squared, subtract k squared, which is 80k squared. Then I've got 3 times by 21k, subtract 3k, which is 60k. Then I've got 3 times by 2, subtract 2, which is 4. And I divide all this by 12. So I've still got the k times by 3k plus 1. Now from this quadratic term, I can factorize out of 4, leaving me inside the bracket 20k squared plus 15k plus 1, and I divide all this by 12. 4 over 12 is a third, so we end up with k times by 3k plus 1 times 20k squared plus 15k plus 1 all over 3. So A is 20, B is 15, C is 1. Part C. Hence, using algebra and making a method clear, determine the value of k for which 25 times by r squared times r plus 1 from r equals k plus 1 to 3k is equal to 192k cubed times 3k plus 1. So we've got the given equation here. Now, what we can do is use the result from part B here and multiply it by 25. So I've got 25 multiplied by k times by 3k plus 1 times 20k squared plus 15k plus 1 all over 3 equals 192k cubed times 3k plus 1. If I multiply through by 3, on the left hand side we would have 25k times 3k plus 1 times 20k squared plus 15k plus 1, and on the right hand side we have 576 multiplied by k cubed times 3k plus 1. Now, what you will find is the 3k plus 1 cancels on both sides. So we have 25k times by 20k squared plus 15k plus 1 equals 576k cubed. And now we can divide both sides by k, leaving us with 25 times 20k squared plus 15k plus 1 equals 576k squared. So now if I multiply 25 by this bracket, we have 500k squared plus 375k plus 25 equals 576k squared. So I have 76k squared subtract 375k subtract 25 equals 0. Let's now solve this. We can do this using the equation solver on our calculator. We have a polynomial of degree 2. We have 76k squared subtract 375k subtract 25 equals 0. So we will have k equals 5 and k equals minus 5 over 76, meaning k equals 5 only. Question number 4. We've got the matrix A shown here and the matrix B shown here, and k is a constant. Part A. Determine the value of the constant C for which A multiplied by B is equal to 3k plus C multiplied by the identity matrix I. So for part A, we've got the matrix A multiplied by the matrix B, which is equal to 3k plus C multiplied by the identity matrix I. Now, what we can do to find the value of C is look at the element here. How do we get this element? Well, we multiply this row by this column. So if we do that, we've got negative 1 multiplied by 4k subtract 2 plus negative 2 multiplied by 10 plus negative 7 multiplied by 3 subtract k, and this will equal 3k plus C multiplied by 1. So if we tidy this up, we end up with 3k plus 1 equals 3k plus C. And so comparing the number terms, you can see we've got 1 on the left hand side, C on the right hand side, so C equals 1. Part B, hence determine the value of k for which the inverse of A does not exist. Now, we've got this equation AB equals 3k plus C multiplied by I, and we've just worked out C to be 1. So, we've got A multiplied by B equals 3k plus 1, remember C is 1, multiplied by I. Now, for the inverse of A to exist, 3k plus 1 cannot equal 0, otherwise A multiplied by B will just give us 0 multiplied by I, which is just 0. Which means then, the inverse of A does not exist when k equals negative 1/3. Given that the inverse of A does exist, part C, write down the inverse of A in terms of k. We've got the equation AB equals 3k plus 1 multiplied by I. Now, what we can do is recognize that k is a constant, and we can therefore divide both sides by 3k plus 1. So I have A multiplied by 1 over 3k plus 1 B equals I. And if I multiply both sides by the inverse of A, we have the inverse of A multiplied by 1 over 3k plus 1 B equals I multiplied by the inverse of A. You can think of A inverse times by A to equal 1 essentially, and I multiplied by A inverse will just be A inverse. So therefore we have on the left hand side 1 over 3k plus 1 times B equals A inverse. So A inverse is equal to 1 over 3k plus 1 multiplied by the matrix B, which is shown here. Part D. Use the answer to Part C to solve the simultaneous equations. Negative x subtract 2y subtract 7z equals 10, 3x plus ky plus 2z equals 3, x plus y plus 4z equals 1, giving the values of x, y and z in simplest form in terms of k. To do this question, we need to recognize that the coefficients of x, y and z is just the matrix A. You can see here we've got negative 1, negative 2, negative 7. Here we've got negative 1, negative 2, negative 7. We've got 3k and 2, 3k and 2, 1, 1 and 4, 1, 1 and 4. So we can write that equation in matrix form. So I've got this matrix multiplied by x, y, z equals 10, 3, 1. So I've got A multiplied by x, y, z equals 10, 3, 1. To find out what x, y, z is, we have to multiply both sides by A inverse. So in other words, x, y, z is equal to A inverse multiplied by 10, 3, 1. And we already know what A inverse is. We work that out over here. So I've got A inverse, which is shown here, multiplied by 10, 3, 1. So I've got 1 over 3k plus 1, and then I've got 4k subtract 2 times 10, plus 1 times by 3, plus 7k subtract 4 times 1, that's 47k subtract 21. Then I've got negative 10 times by 10, plus 3 times by 3, plus negative 19 times by 1, that's negative 110. And then I've got 3 subtract k times 10, plus negative 1 times 3, plus 6 subtract k times 1, which is 33 subtract 11k. And so this is what the vector x, y, z is equal to. Question number 5. Given that on an Argand diagram, the locus of points defined by mod of z plus 5 subtract 12i equals 10 is a circle, part A, write down the coordinates of the centre of this circle and the radius of this circle. We will begin by letting z equaling x plus yi. So therefore, this mod of z plus 5 subtract 12i equals 10, we will replace the z with x plus iy, and therefore this will become the mod of x plus 5 plus y subtract 12i equals 10. What we have here is a circle with centre negative 5, 12 and radius 10. Part B. Show by shading on an Argand diagram the set of points defined by mod of z plus 5 subtract 12i is less than or equal to 10. What we need to do to begin with is draw a circle with centre negative 5, 12 and radius 10, and we want everything inside that circle shaded in. And that's what we see here. We've got a circle with radius 10 and we've got the centre negative 5, 12. For the set of points defined in part B, we have to determine the maximum value of mod of z. The maximum value will be the length of this line here. So what we need to do is find out the distance from the origin to the centre and then add on the radius, and that will give us the total length. So OC will equal 5 squared plus 12 squared, which is equal to 13, and so therefore mod of z max will equal 13 plus 10, which is the radius, and that's equal to 23. The set of points A is defined by A equals, well, we've got the argument of z plus 5 subtract 20i being greater than or equal to 0 but less than or equal to pi, and we've got the mod of z plus 5 subtract 12i is less than or equal to 10. Part D. Determine the area of the region defined by A, giving your answer to 3 significant figures. The first thing we need to do is determine the point at which we have essentially a centre here, and that will be at minus 5, 20. We then need to recognise that this will be a horizontal line because it's bounded between 0 and pi, and the area will be in between these two, and that is shown here. We've got this horizontal line, and it's a horizontal line because we are going from 0 to pi, and the bit in green is the area we need to work out. The distance from the centre to this point here will be the radius, which is 10, and from here to here is also 10. The angle in between them is given by theta, and to find out what theta is, we can construct a vertical line from this point here and use trigonometry to work out this angle here. And the length of this line here, well, we are going from 12 to 20, so that has a length of 8. So we can use trigonometry with this right angle triangle. We've got the hypotenuse, which is 10, and the adjacent, which is 8, and the angle will be theta over 2. So we've got cos of theta over 2 equals 8 over 10. And now what we can do is work out what theta is. We have the inverse cosine of 8 over 10 multiplied by 2, and it turns out theta is equal to 1.287 radians. So what we can now do is work out the area of the sector and then the area of the triangle, and the required area is the difference between those. So the area of the sector is a half times by 10 squared times by 1.287. So I need to multiply this by 1/2 times by 10 squared, and it turns out we get 64.4. The area of the triangle, well, if we use Pythagoras for this length here, that will be 10 squared take away 8 squared square rooted, which is 6, so the total length here will be 6 plus 6, which is 12. And then we can use a half times base times by the height to work out the area of the triangle. So we have a half times 12 times by 8, which is 48. So therefore the area of the segment is the difference between these two. We have 64.4 take away 48, which is 16.4. The drainage system for a sports field consists of underground pipes. This situation is modelled with respect to a fixed origin, or, according to the model, the surface of the sports field is a plane with equation z equals 0. The pipes are straight lines. One of the pipes, P1, passes through the points A with coordinates 3, 4, negative 2, and B with coordinates negative 2, negative 8, negative 3. A different pipe, P2, has equation x subtract 1 over 2 equals y subtract 3 over 4 equals z plus 1 over negative 2. The units are meters. Part A, determine a vector equation of the line representing the pipe P1. For us to do this question, we need to first of all work out the direction vector. So we can work out the vector BA. That's OB take away OA. So I've got 3i plus 4j subtract 2k, subtract negative 2i subtract 8j subtract 3k. And it turns out we get 5i plus 12j plus k. It passes through the point A with coordinates 3, 4, negative 2. So P1 would have equation r equals negative 3i plus 4j subtract 2k plus lambda multiplied by 5i plus 12j plus k. Part B. Determine the coordinates of the point at which the pipe P1 meets the surface of the playing field according to the model. For part B, we've got the plane over here with equation z equals 0, and then we've got the line P1. A general point for xyz will be given by 3 plus 5 lambda, 4 plus 12 lambda, negative 2 plus lambda. We know that when z equals 0, that is when P1 intersects the plane, so I can set the z component equal to 0. So I've got negative 2 plus lambda equals 0, meaning lambda equals 2. Substituting back into here, for the x we've got 3 plus 5 lambda, so we have x equals 3 plus 5 times by 2, which is 13, and for y we've got 4 plus 12 lambda, so we've got y equals 4 plus 12 times by 2, which is 28. So P1 would meet pi at 13, 28, 0. And that is shown here. Determine, according to the model, the acute angle between pipes P1 and P2, giving your answer in degrees to 3 significant figures. For part C, the first thing we can do is state the direction vector of P1, that's 5i plus 12j plus k. We can now find out the magnitude of this. 5 squared plus 12 squared plus 1 squared, all square rooted, that's the square root of 170, so the magnitude is square root 170. If I take a look at the equation for P2, you can see here we've got the 2, the 4 and the negative 2. So the direction vector of P2 will be given by 2i plus 4j subtract 2k. So for the magnitude of this we've got 2 squared plus 4 squared plus negative 2 squared, all square rooted, so the magnitude is root 24. We can find out the angle between them by using R1 dot with R2 equals magnitude of R1 times magnitude of R2 times by cos theta. So we've got 5i plus 12j plus k dot with 2i plus 4j subtract 2k equals square root 170 times square root 24 times cos theta. So for the dot product of these two vectors, we've got 5 times by 2 plus 12 times by 4 plus 1 times by negative 2, and that will equal square root 170 times square root 24 times cos theta. On the left hand side I've got 56 and the right hand side remains unchanged. So cos theta will equal 56 over square root 170 times square root 24. And from this we can find out what theta is. I've got the inverse cosine of 56 over the square root of 170 times by square root of 24, which is equal to 28.8 degrees. Part D, we have to determine according to the model the shortest distance between pipes P1 and P2. To begin with, let's state the vector for P1. That's r equals 3, 4, negative 2 plus lambda multiplied by 5, 12, 1. And so a general point on P1 will be given by 3 plus 5 lambda, 4 plus 12 lambda, and negative 2 plus lambda. We can rewrite the equation for P2. P2 will be given by r equals 1, 3, negative 1 plus mu multiplied by 2, 4, negative 2. And so a general point on P2 will be given by 1 plus 2 mu, 3 plus 4 mu, negative 1, subtract 2 mu. Here we have P1 and P2 with those points on them. Now, the shortest distance between two skew lines is when the connecting vector is perpendicular to both direction vectors. And that's what we see here. So to begin with, we can find out the connecting vector AB. So we have 3 plus 5 lambda, 4 plus 12 lambda, negative 2 plus lambda, subtract 1 plus 2 mu, 3 plus 4 mu, negative 1 subtract 2 mu. And working this out, we've got 2 plus 5 lambda subtract 2 mu, 1 plus 12 lambda subtract 4 mu, negative 1 plus lambda plus 2 mu. So now we need to work out this direction vector dot with the direction of P1, and then this direction vector dot with P2. So I've got AB dot with 5, 12, 1 equals 0. So I've got 5 multiplied by 2 plus 5 lambda subtract 2 mu, plus 12 multiplied by 1 plus 12 lambda subtract 4 mu, plus 1 multiplied by negative 1 plus lambda plus 12 mu equals 0. So I've got 10 plus 25 lambda subtract 10 mu, plus 12 plus 144 lambda subtract 48 mu, subtract 1 plus lambda plus 2 mu equals 0, and simplifying, 170 lambda subtract 56 mu equals negative 21. Let's call this equation 1. And for the next equation, we've got AB dot with 2, 4, negative 2 equals 0. So I've got 2 times by 2 plus 5 lambda subtract 2 mu, plus 4 multiplied by 1 plus 12 lambda subtract 4 mu, subtract multiplied by negative 1 plus lambda plus 2 mu equals 0. So I've got 4 plus 10 lambda subtract 4 mu, plus 4 plus 48 lambda subtract 16 mu, plus 2 subtract 2 lambda subtract 4 mu equals 0. So I've got 56 lambda subtract 24 mu equals negative 10. Let's call this equation 2. And now what we can do is solve these two simultaneously. So let's go to the equation submenu. We've got a simultaneous equation with two unknowns. We've got our first equation, which is given by 170 subtract 56 equals negative 21. And then we've got 56 subtract 24 equals negative 10. So we've got lambda equals 7 over 118. And mu equals 131 over 236. What we can now do with these is substitute this back into AB. In doing so, for AB, we've got 2 plus 5 times 7 over 118, take away 2 times by 131 over 236. Then we've got 1 plus 12 times 7 over 118, take away 4 times by 131 over 236. Then we've got negative 1 plus 7 over 118 plus 2 times by 131 over 236. And working this out, we have 70 over 59, negative 30 over 59, and 10 over 59. So the shortest distance, we've got 70 over 59 squared plus negative 30 over 59 squared plus 10 over 59 squared, all square rooted. So let's work this out. We have the square root of 70 over 59 squared plus negative 30 over 59 squared plus 10 over 59 squared it turns out we get 1.30 meters. Question number 7. For the first part, we have to prove by induction that for all positive integers n, the sum of 1 over r times r plus 1 from r equals 1 to r equals n over n plus 1. With these types of questions, it's always useful to write down what we want to show. Essentially, we want to replace the n with k plus 1. So we want to show that the sum of 1 over r times r plus 1 from r equals 1 to k plus 1 is equal to k plus 1 over k plus 1 plus 1. We've replaced the n with k plus 1. So our first step is to look at what happens when n equals 1. If we take a look at the left hand side, we have the sum from r equals 1 to 1, which is given by 1 over 1 times by 1 plus 1. We've replaced the r with 1, and that's equal to 1/2. And now we also have to do the same thing on the right hand side by setting n equal to 1. So we've got 1 over 1 plus 1, which is 1/2. And because the left hand side is equal to the right hand side, the result is true for n equals 1. Our second step is to assume that the result is true for n equals k. In other words, the sum of 1 over r times r plus 1 from r equals 1 to r equals k over k plus 1. For the third step, we have to prove the result is true for n equals k plus 1. So, we've got the sum of 1 over r times by r plus 1 from r equals 1 to r equals k plus 1. Now what this is equal to is the sum from r equals 1 to r equals k plus the next term after this. And the next term after this will be the k plus 1th term. So we add on 1 over k plus 1 times by k plus 1 plus 1. So we've replaced the r with k plus 1. So this is the term after the kth term. And now the rest of the steps is just algebra. So we've got k over k plus 1, so that's using our induction step from step 2. And we add on to this 1 over k plus 1 times k plus 2, because k plus 1 is just k plus 2. So I've got this k over k plus 1, and I'm going to multiply both the numerator and the denominator by k plus 2. And then I add on to this the next term, which is 1 over k plus 1 times k plus 2. We've got this common denominator of k plus 1 and k plus 2, so we can combine the numerators. So we've got k squared, that's k times by k, plus 2k plus this 1. Now k squared plus 2k plus 1, that's just k plus 1 squared, and we divide this by k plus 1 times k plus 2. So we end up with k plus 1 over k plus 2. So on the top we've got k plus 1, and on the bottom we've got k plus 1 plus 1, which is k plus 2. And that's what we wanted to show. For our fourth step, we have the conclusion. If it's true for n equals k, then it's been shown true for n equals k plus 1, and as it is true for n equals 1, the statement is true for all positive integers of n. For the second part, we have to prove by induction that for all positive integers n, f of n equals 3 to the power of 2n plus 4 subtract 2 to the power of 2n is divisible by 5. So for the first step, let's try for n equals 1. So f of 1 will equal 3 to the power of 2 times by 1 plus 4 subtract 2 to the power of 2 times by 1. Here we get 725, which is equal to 5 times by 145. So this is certainly divisible by 5. Therefore, it's true for n equals 1. The second step, we have to assume the result is true for n equals k. In other words, f of k equals 3 to the power of 2k plus 4 subtract 2 to the power of 2k is divisible by 5. For our third step, we have to prove the result is true for n equals k plus 1. So I've got f of k plus 1, that will equal 3 to the power of 2 times by k plus 1 plus 4, subtract 2 to the power of 2 times by k plus 1. Now, if we take a look at the powers and simplify, we would end up with 3 to the power of 2k plus 6, subtract 2 to the power of 2k plus 2. And what we need to do is make this result similar to what we have over here. Here we've got a 3 to the power of 2k plus 4. We need to somehow adjust this. And here we've got a 2 to the power of 2k. We somehow need to adjust this. And what we can do is use the laws of indices. So I've got this term, which I can rewrite as 3 to the power of 2k plus 4 plus 2, subtract 2 to the power of 2k plus 2. So I've got 3 squared times by 3 to the power of 2k plus 4, and if I add the powers because I've got the same base, I end up with 2k plus 4 plus 2. And here I've got 2 to the power of 2k times 2 squared, because if I add the powers because I've got the same base, I end up with 2k plus 2. 3 squared is 9, so I've got 9 times by 3 to the power of 2k plus 4, subtract 4, because 2 squared is 4, times by 2 to the power of 2k. This here is similar to what I have over here. So now if we work out what f of k plus 1 subtract f of k is, we've got f of k plus 1, which is 9 times 3 to the power of 2k plus 4, subtract 4 times 2 to the power of 2k, subtract f of k, and f of k is 3 to the power of 2k plus 4, subtract 2 to the power of 2k. Now, I've got 9 times 3 to the power of 2k plus 4, subtract 3 to the power of 2k plus 4. So that means I have got 8 times by 3 to the power of 2k plus 4. And then I've got negative 4 times 2 to the power of 2k, subtract negative 2 to the power of 2k. So that's negative 3 times 2 to the power of 2k. Now here we can adapt this so we somehow work with this. Now the way we can do this is to recognize that negative 3 is the same as negative 8 plus 5. So I've got 8 times 3 to the power of 2k plus 4, subtract 8 times by 2 to the power of 2k, plus 5 times by 2 to the power of 2k. Negative 8 plus 5 is negative 3. And from these two terms, we can factorize out an 8. So I've got 8 multiplied by 3 to the power of 2k plus 4, subtract 2 to the power of 2k. And what this is f of k. And don't forget, we add on 5 to the power of 2 to the power of 2k. So I've got 8 times by f of k plus 5 times by 2 to the power of 2k. And remember, this is what f of k plus 1 subtract f of k is. So now if I add f of k to both sides, f of k plus 1 will equal 9 times f of k plus 5 times by 2 to the power of 2k. Now here, we know that f of k is divisible by 5, so 9 times by f of k will be divisible by 5, and that's through the second step where we said f of k is divisible by 5. And of course 5 times by 2 to the power of 2k will be divisible by 5 because we've got 5 times something. So this is also divisible by 5, meaning f of k plus 1 is divisible by 5. So for our fourth step, which is our conclusion step, we would have, if it's true for n equals k, then it's been shown true for n equals k plus 1, and as it is true for n equals 1, the statement is true for all positive integers of n. Question number 8. Figure 1 shows the central vertical cross-section OABCDEO of the design for a solid glass ornament. Figure 2 shows the finite region R, which is bounded by the y-axis, the horizontal line CB, and the vertical line BA, and the curve AO. The ornament is formed by rotating the region R through 360 degrees about the y-axis. The curve AO is modelled by the equation x equals ky squared plus square root y, where y is in between 0 and 4 and k is a constant. The point A has coordinates 0.44 and the point B has coordinates 0.4, 4.5. The units are centimetres. Part A, determine the value of k according to this model. All we have to do is substitute in this point into this equation. So we've got 0.4 equals k times by 4 squared plus square root 4. So if I solve for k, we end up with k equals negative 1/10, meaning x is equal to y to the half subtract y to the half over 10. Part B, use algebraic integration to determine the exact volume of glass that would be required to make the ornament according to the model. Now, if we look at this, what we have is this curved bit, and then we've also got this upper bit. So we can split this up into two parts. We've got this bit, and then we've got this bit. We can work out the volume of this curved bit by considering a volume of revolution about the y-axis, and here we've just got a cylinder. So we know that v equals pi times by the integral of x squared dy. So the volume of v1, using the fact that x equals the result here, that's equal to pi multiplied by the integral from 0 to 4 of y to the half take away y squared over 10 squared with respect to y. So I've got pi times the integral from 0 to 4 of y subtract y to the 5 over 2 over 5 plus y to the 4 over 100 dy. So I've got pi multiplied by, now if I integrate this, we have y squared over 2 subtract 2 y to the 7 over 2 over 35 plus y to the 5 over 500 between 0 and 4. So I've got pi multiplied by 4 squared over 2, take away 2 times by 4 to the 7 over 2 over 35 plus 4 to the 5 over 500, take away 0. So let us work out what this is equal to. We have 4 squared over 2, take away 2 times by 4 to the power of 7 over 2 divided by 35 plus 4 to the 5 over 500, and then of course we multiply that by pi. So we have 2392 pi over 875. And for the volume of 2, we can recognize we've got a cylinder. We would have a radius of 0.4, that's this distance here, and the height, well, what we know is we've got 4 and 4.5, so the height over here will be 0.5. So v2 will equal pi times by 0.4 squared times by 0.5, which is 2 pi over 20. So if I add on to this 2 over 25 and then multiply that by pi, what we will end up with is 2462 pi over 875. Part C, state a limitation of. Well, the sides of the ornament may not be perfectly smooth. When the ornament was manufactured, 9 cm cubed of glass was required. Part D, use this information and your answer to Part B to evaluate the model, explaining your reason. If I find out what this numerical value is, I get 8.839, etc. So the volume is equal to 8.84 cm cubed, which is approximately 9 cm cubed. So therefore the model is suitable.